Hello everyone. In this video we will talk about Entity Framework 4 and this is about data. When we talk about the data, usually we think about the persistence layer in our applications. Like data, we process a lot of data in our applications and most of the time we have to persist that data. We process the data into memory and then we have to persist it, and we persist it into the database. And when we think about persisting a database, we have to think it in a special way, like the data should be organized and structured according to the persistent requirements. Like we think of how will we retrieve the data, what will be the keys, what will be the indexes, how the data will be sorted, what we do so the insertion is fast and the retrieval of the data is fast and information is organized properly, takes less space, and all these kind of scenarios we have to think when we actually design our database or when we design our data for the persistence. So we put indices for better performance, and we use foreign keys to set up the relations between different objects. But the same data, when we think in the business layer, we design things in the business layer, the relationship is a bit different, or the behavior or the design is a bit different, because in business layer we do not think of the data objects as we think like in persistence layer. In persistence it's about storage, it's about retrieval. But in business, we take objects as they behave in real life. We do not think of their persistence behavior. We have attributes and the way they behave. So attributes are there to store the information about the objects, and behavior is like the methods about how that object will perform. So there is this difference when we talk about the same data in persistence layer and the same in the business layer. For example, we can see here, this is our business layer. In business layer we have a relation of, we have some artist here and then the album. So some artist or one artist can have more than one albums, and similarly it is possible like many artists worked on the same album. So in that case one album is related to more artists. So there is an end-to-end relationship between the artist and the album. And in business layer we will have, say, artist first name, middle name, last name, and all of its attributes. So all the attributes that this artist has worked on will be or should be available as a collection of albums into the same object. And when we come to the album, we say what is the album ID or album name and how many artists worked on this album. So relation n to n is represented like on both sides we have collection of the related object. But when the same objects are designed for persistence, the situation is a little bit different here. So we have artist here, then we have albums here, and their end-to-end relationship is mentioned by a middle table which doesn't exist in the business layer. So this middle table, or known as link table, contains the artist ID and the album ID, and from this link table we come to know which artist has worked on which albums and which album has produced by how many artists. And similarly, in another situation, when we want to implement child parent relationship or kind of hierarchy, in business layer we have a name, and so say we want to implement categories, and a category can have subcategories, and then again within the subcategory each subcategory may have another subcategories as well. And if this relationship is like a tree, so what we have is whatever our category is and what are its subcategories and what is the parent category of this one. So at any place a category will have subcategories and a parent category. If it is the top first one, then there is no parent but all the subcategories. And if it is the bottom one, then it will have a parent and subcategories collection will be null. Now the same thing when we try to do in database, it's a bit different, because in the same table we have category ID and the parent category ID, and there is no subcategories. So from this parent category ID, we check, okay, if it has a parent or not, and then we go to all the categories and check, sort out its parent categories, and where the parent category is null, then we say, okay, this is the top one, and where the parent category is not null, then we go to that category and find out, okay, so we store it in this way. So we see the difference in this kind of data. And sometimes what happens is, like for performance reasons, we have to split or divide one object into multiple tables when it comes to persistence. For example, there is a product has a name and description, price, and when it comes to the image, we say, okay, to get the better performance, we store images to a separate table. So we have a separate table here which stores images only, and the other tables which contains only the information, not the information which is less information, doesn't take much space. So they are contained separate, because most of the time we are searching on this table, and if this table stores images as well, this table will get huge in size, and our search will not be that fast. So for performance reasons, we take out the large amount of data and store it into a separate table. But when we talk about the product in real life, there is no separation. So the image, product, description, and everything is at the same level. Okay, and next is there could be situations like, we have a yeah, here is the example where we have a base and then we have a derived object as well, like specialized objects. So we might have some employee, and then within employee we might have specialization, like some agent or some developer or something else. So we can also have a base object and a derived object as well, and they obviously there will be a difference between the storage persistence and the real life, the business object as well. So we have discussed, like, there are differences in data when we talk about in different contexts. Like when we talk about the persistent context, they are designed and the approach is different, and when the same object we talk in the business layer, the approach is different, and in the business layer we try to look as closer as to the real life. So in business layer, the objects are as if they are real objects, and we know this difference because we have to store them in database, and in programming we have to deal them in business layer. So this difference we have to work out, and we have to map these differences, because when we do some processing and go to the database, we have to, from the business context, we have to switch to the persistent context, and when we load the data, it is in the persistence context or persistent way, and then we have to do some processing, we have to bring back to the business way. Okay, and how we have been doing these kind of things so far, like in Visual Studio, we have had this ADO.NET data sets, and within those data sets we have data adapters. Data adapters are kind of bridges between the database and the data tables, like in-memory database and the persistent database. And we use data adapters to execute and connect to database and execute queries, and when the query is executed, it fills the data tables which are part of a data set. And within the data set we have table. Table is a collection of data rows, and then data row is a database record. Okay, it works fine, but so it works fine, like we have a data adapter, and we say data adapter connect to this database, execute this query, and fill me this table. Now when the table is filled, we have all the data that is filled based on a certain query, and this data is into memory, and we can manipulate and process the data into memory. And this data into memory is a collection of data rows, because it's a table, and table is a collection of data rows, and each data row represents the attributes or the fields of the columns in database, and it works fine. But the problems come when we want to use these data rows into our business object. For example, we have a business data access layer which is returning something to a business layer, or business layer which is returning something to the client. In data access layer we have data table and data rows, but when we return the objects to the business layer, they are not, or they cannot be the data rows, so they have to be the objects, DTOs, the business objects. Now, as I said, there are differences, like the data row may be different than the business object, so we have to map these data rows to the business object. That means we copy or create an object of the business object and copy all the properties from the data row to the business object and then hand it over to the business layer. And when some update or insert command comes from the business layer, we get the business object, and within the data access layer, that business object or all of its properties are then copied to a new data row or the existing data row, and then the insert or update command is executed. So we have some extra work to do when we are passing our data from the data access layer to the business layer, or vice versa. Okay, so what is happening with this approach? The thing is, we have been writing more code because we have been doing some special or extra work to deal with the situation. And to fill this gap, like persistent and business layer, this more code is being written, and this more code, we need to analyze what does this mean, writing the more code. And the other thing is, when we do the queries, we queries the database. For example, to data adapter, we say, okay, here is your query, and query is a T-SQL or SQL command. So it's like select this from this, where this condition, and that is a string. It's a string. We give that string to the data adapter to execute it as a T-SQL or SQL command and get the results and fill the data table. Then we create the separate business object to create separate business objects and data rows. That is also like more work. Then we have to write the code to copy the business object and data rows as well. Okay, now what does more code mean? More code obviously means more number of bugs, because it is impossible to write code that doesn't have any bugs. So there are no programmers which can write bug-free code. And even if there are, suppose there are some programmers who can write bug-free code, all these big companies would have hired them. So, but what happens for the rest of the companies? So we have to accept this fact, like when we write code, there are chances of bugs in it, always. Now, each bug has a cost to it, and it really matters for the companies to have less bugs. So we write the code in a way so that it has less bugs. And one of the option is to write less code. But before we talk on that, let's check what is the cost of a bug into the code. The cost of a defect into our code varies in different phases. For example, if a bug is caught while the developer is developing the code, and during the same phase, like the developer notices, oh, there should be this if condition, or I need to check if the object is null or not, or if this condition is missed, and the developer immediately fix it without somebody else notices. So this is the minimum possible cost. Like it might be a few minutes of work and the bug is fixed. But now if different programmers or developers are working on different parts of the system, and when those different parts are combined or integrated to each other, if at that integration stage we find the bugs, the cost is more. The cost to fix this bug now has increased. So it could be like hundreds of pounds, because then when we integrate the system, we go through different functionalities, test it, so somebody is testing it and then reporting back, okay, here is the bug, this is the scenario. Then the developer has to recreate that scenario, debug into the system and see and fix the issue. So it takes more time. So now the cost is increased. Now imagine the system has passed this integration stage, and is deployed in production and is live. And if at that stage we find a bug into the system, how much it costs? It may cost thousands of pounds to fix it, because now we have to follow the whole procedure. First of all, even before the fix, the bug might have caused a lot of damage before it is captured even. Or if not, luckily, then just to fix it, now there is long process. So the bug will be reported, and there should be some process to log it somewhere, and then based on that log sheet, the bugs based on their priorities are allocated, like, oh, this bug is immediate, is high priority, we need to fix it. Then the developer has the code, the latest code from the source, or from the code base. He will get the code and debug, create the scenario, debug the system, fix the bug, and when the bug is fixed, the developer will test it. And now the developer has to test it based on the whole system. Then it might go to DAT system or UAT for testing, for quality assurance, for the approval. And no, when the whole system is there, it's not only testing that one bug. We have to test the whole system and have to execute so many test scenarios to pass the whole system for the release, because it will be a new release. So we have to follow all the procedures, so the release may take place. So it not just to fix this bug, there is an effort of days and many people involved in it, and a quite long procedure. So obviously at this stage the bug will, or the defect will, cost thousands of pounds to fix it. And also, when we talk about the software development life cycle, we have different phases like requirement gathering, analysis, design, development, and testing. And then after the testing, the product goes live in operational state, and the operation and maintenance state, or the phase, is 60 to 70% of the cost. So we can see all the other phases where we do the analysis, where we design, develop, and test the product, takes less than 50%. So more budget, more than half of the budget is going to operate and maintain the system. One of the reasons is because we have issues. We need to constantly work on fixing the issues and improve the system and bring new features, and we have to go through all the QA procedures, release procedures, and then bring the system to the live. So this whole maintenance and operation phase cost more than all the previous phases. Now how can we bring this cost down? That is the point. And also, we, like most of the companies in these kind of tough financial situations, this is common, like the management is saying, oh, this year will be tough, or next year will be tough, and we have to work hard, or we have to do these kind of actions to continue or improve, or blah blah blah. So we really need to think about how can we reduce the cost. And obviously here we are talking about writing the code or developing the software. So the cost, the major cost, is the defects or the bugs that are left behind within the code. Okay, so there is one simple way to reduce the number of bugs. One option is, if we write less code, there will be less number of bugs, because more code means more bugs. And the other option is detect and fix the bugs as early as possible, like we test the code immediately. So if you follow the test driven development, then there is a chance like we leave less bugs when we go to integration phase. And any other option in mind? Well, the other option is, let's start some modeling. Wow, so we get a model, we become a model and earn money. We don't worry about the bugs and any of these issues. But that's not easy for all of the developers to become immediately a model. So suggestion is, don't switch all of a sudden. So continue some coding and then do some modeling as well. But how the developers can do modeling? Well, there is a different approach, and that is entity framework. What is entity framework? It's a collection of technologies for developing data related applications. It's kind of ORM, object relational modeling, and this is not a new concept. It's been there for years, in fact decades. And this process hasn't come up all of a sudden. It's been evolved. The people have been thinking on these kind of things for many years, and now, because we have all the programming languages and development environment so much sophisticated, like now it's a time to really have something working on the ORM things. And it's query against the object and not the database. As I mentioned earlier, in our dataset approach, we used to query the database. So we used to say, okay, select this from table this, where column this equals this. But in entity framework and in ORMs, we do not go to the database level. We stay one level up to the database and we query the objects that are our business objects. Now, what will be the real query? We don't know. We don't need to worry about. That's all transparent to us. It's happening behind or below the business layer. And these frameworks like entity framework, they will handle what will be the query that will be sent to the database, how it will be executed, what will be the how the database connectivity will be handled. But what we do in here is we query against the business object and we get a list of the results. That's it. All the rest of the things, connectivity to the database, executing the SQL or T-SQL, getting the results from the database and mapping to the business objects is all happening by these frameworks for us. Okay, so what we do in entity framework, we do some modeling, and when we talk about the modeling, it's the Visual Studio that gives us a designer where we can model our objects, we can relate our objects, we can define our attributes, relations to other objects, and once our data model is complete, then we can go and generate the database on our model as well. And in entity framework, there are three categories or three things that we say when we talk about the entity data modeling. We say there is a conceptual layer, there is a mapping layer, and there is a storage layer. So if we think like this storage layer is what we talk about the persistence layer. So this storage layer is responsible of how the data will be stored into the system and what is the best way to store the data into the system. And then the conceptual layer is the way we look into our business layer. So how the object should look like into the business from the business perspective. And all those differences are then mapped or taken care by this mapping layer. So this mapping layer then do all the mapping from the conceptual layer to the storage layer. Takes care of all the differences between the mapping layer, the storage layer and the conceptual layer. Okay, and we have this EDM designer. We can create a project into Visual Studio and then we can add an object. It's ADO entity data model object, and when we add that object we get a designer and where we can model our business object. So say we have a job and from the job we have batches. So one job can become more than one batches, so 1 to n relationship, and then within a batch we have some cards. So we can set up this relation and we can put these properties or attributes of the object, and these are the relations like when we talk about job has its attribute job ID, file name, order date, product, and how many batches it has. When we come to batch has its attributes, and then we can say how many cards this batch has and what job this batch is related to. And when we come to the card attributes and what batch this card relates to. So once this modeling is complete, we can go and ask the designer to create a script, and that script will generate all the database behind this model. But entity framework has works on two approaches. One is the model first, which we discussed, like we open the designer and model our business data objects, and based on our model we then generate the database. The other approach is like the usual one that we have been doing in data sets, and these kind of approaches like we design our database first into SQL Server or Oracle or anywhere, and then we come to the entity data model wizard and say generate from the database. So we have database already existing, we select the database and ask the designer to generate or to model our business objects based on the existing database. Okay, so yeah, to work in the entity framework, as I mentioned, we model our entities first. And once the entities are modeled, then we have to create an object context class. So this object context class consists of object sets and manages, and it's kind of bridge to SQL Server or our SQL. So the object context class consists of object sets, and then all the handling of connecting and executing the queries to the database is handled by the object context class. And we ask the object context to give me the objects of this type, and then object context then handles all the connectivity, generation of SQL commands, execution, getting the results back, and returning the business objects. And as we said earlier, we query the business objects or query the model, not the database. Here are a few examples how can we query the model. The one is like the conventional way, like we do in the SQL. So we have a query, select star from students where degree is this. So it's a parameter, and then we create the DB parameters, we set the value of the parameter, and then we have this context class. This is the context class that we just talked, like we need this object context class which contain object sets and handles all the connectivity to the SQL. So this is the context class object. We say execute store query and we pass that string. This is a string query and all the arguments, and it returns these collection, the students. So what it will do, it will take this string as a query and set these parameters, connect to the database, execute the query, bring the results or the records back, and then from those records it will build up the student type collection. So if 3 students are returned, it will return a collection of 3 students. Student means this object, the student object, which is already defined as a class or as an object into our model, into our entity data model. And obviously at the end it's a class having some attributes or properties, and this is the collection of these student type of objects. And then we can go through each student and we can work out what each student is. Okay, next approach is could be like we say we create the objects context object, and then we create the query, and this query you see is different. It's not a SQL query. We say select value C from customer C. Okay, this is using the object services. So this is, we're not querying against the database like we did here. We are querying against the objects. So customers is the object set here. As we said, this is the object set contained or as a property of the object context class. So object context class will contain all the object sets that it works on, and then we query these objects, these object sets. Okay, so we say select value C from customers as C, and then we execute, we say context create query. So over here we say execute store query. Store query means database query, and here we create query and we pass our string value over here. So this string query is not actually the query that is the T-SQL that works on a T-SQL. It's a query on the object, and now the context class will generate the T-SQL query from this query that is done on the object base, and it will then get back the customers from the database, and these customers are of type this customer, which is a business object. So we are straight away getting the business object instead of data row or anything, which we don't need to really worry. We don't need to write any code to map the database record or any other kind of record to our business object. We straight away get a collection of business objects, and then we can execute for each command or do anything with this collection. Okay, and similar is like entity SQL. We can select value C from, this is another example, and if we don't want to get the collection and we want to get some kind of reader so that we can go through the reader and we read our own way, then we can have this reader object as well based on this query. But what is the different, what is something new and something really that you can, that you may like, is this link. The link is language integrated query. What is this language integrated query? Just look at this query. It says we have a context object and we say from post in blog post where post.comments.any and select post. You note the difference, like this, this is a query and it's not a string. It is not within the quotes like these queries. So you put the quotes and within the quotes you write a string. No, it's not like that. It's part of the language. This syntax is part of the language. Like you can see, from is a reserved word, in is a reserved word, where is a reserved word. And when you say from post in context dot blog post, you say context dot, you IntelliSense automatically lists you the blog post, all the objects available within the context, all the data sets or the objects available within the context. And when you say where post, it automatically lists you post.comments, and then you can do so the IntelliSense work over here, because this query is part of the language C#. So IntelliSense is there. You don't have a chance to do the spelling or these kind of mistakes. Like in here, you may mistype the degree or any. You may, instead of student, you may say students, or in here you might miss S here and you might write customer, and you don't know. There is no way to detect that error until you execute the query. But over here, the syntax help is there, IntelliSense is there, and if there is a spelling mistake, it is detected at the same time. Now, what happens to this query? This is the links language integrated query, and then it gets translated by the framework to the SQL query. The query is executed and the result is returned into the post. Now this is something new. This is something really that I like in the link query. And I have seen, like in Java, in Hibernate, the framework, it's a similar framework, like we're talking about entity framework, and then we have Hibernate in .NET as well. But I haven't seen this kind of feature in Hibernate. Maybe somebody has written it, but it's not that common. But this link is now by default the integrated part of the entity framework in .NET. So we can straight away use it. We don't need to do anything. Now just look at some of the examples, like how can we set the default value in the query, and how can we return multiple result sets from a stored procedure, comparing against a list of values, applying a left outer join, paging and filtering at group by. So how easy these things are with the entity framework. Okay. In database, if we have to work on, like if there is a value, there could be null value in one of the column or one of the field, and we have to work out, like if the value is null, then return 0, else you return the years worked, whatever. So we will write some query like select e.name, then we will put a case statement into our tsql or SQL command, and we specify different cases within the case. But if the same query, we have to write the same query into entity framework, we will write something this. We say from e in context.employees. This means, like in context.employees, you select name equal to e.name and years worked equal to e.years worked, and this e is just this variable which is declared here, and it's of type employee. So we say from e in context.employees, and then we can put conditions on e. So we say return me e.name and return me e.years worked. But now if years worked can contain a null value, then we can put this operator. This operator means if it's a null value, return 0, else you return whatever is in the years worked. We can return multiple result sets from a stored procedure as well, and the example will be like this. We need to set a connection create a command object, and command type is stored procedure, and then command text will be the stored procedure name. We can open the connection and call the execute reader, and then call the translate. So whatever is returned is translated into jobs, so we get the jobs as a result, and then we can go through all the jobs and see what they contain. Next example is comparing against a list of values. It's like how to use, we have this in command in SQL, like we say select this where ID is in. So we want to select our results based on a number of or based on a collection. So we use the in command into SQL. And how can this kind of situation be done in the entity framework? Okay, in entity framework it's easy. So we say from B in books, like we say we have a collection, if the context contain a collection of books, and we want to say categories. We have already a list of categories which we just prepared. So our categories is like the books that are related to programming or database. So we want to search all the books where category is programming or database, and our link will be select B in context.books where cats contains. So this cats is our existing collection. So this cats contains b.category.name. So this is what is coming from database. So all the categories where name is in here, so like programming and database, in this list it will select all those categories and return as a books over here. Next example is to see how can we apply a left outer join. So let's see. Right, how can we do the join? Say we have products, and then we have another list or table where we store the top selling products. So in the top selling products we have product IDs, while the products table contain all the information about the products. So how can we apply the join? We will say from P in products join T in top sellings. So we have products and then top sellings, and we can join them based on their IDs, like product.product ID and top selling.product ID, and the result set will go into G. And then we can apply order by as well, and say G.default if empty. So if the result or the join contains empty, it will just return the default value into TPS. And on TPS we can do descending order by. And the other good thing into link over here is like we can return the object as we like. We don't have to return the whole product. So say if we only want to return the name and rating, we can say select new, and within the new we say return me p.name and rating only. So the object that will be returned will only contain name and rating. So we will get a list of products containing name and rating based on this join. Next example is how can we do paging and filtering. Okay, to apply paging or filtering we have words like skip and take. So take this example, like we want to select the customer where name starts with RO, and we can specify here like the page index, like the page that we are after is first page, second or third. Say we are after page number 2, and what is the page size? We say only for each page we want 3 records. Then our link query will be context.customers where, okay, this is another way of applying, like we have some methods as well. So customer.where name starts with the match is RO, and then say order by this, and this is the skip. Skip is like in our case we want to select the second page, we say page index and page size. So you skip 2 by 3, so you skip 6 records and then take 3 after skipping 6. So skip 6 records and take 3 after skipping 6 records. So it will take 7, 8 and 9th record and return that page to us. So it's very easy to apply paging and filtering as well. Okay, next example that we will look at it is how can we apply the group by into the link. So let's have a look. Okay, group by is easy. We say select from registrations, context.registration. You apply group and you apply group on registration date. But registration date contains time as well. So if we want to only apply on the date, then we have a function entity functions.truncate time, and what is left behind is the date. So it will apply grouping onto the registration date only, not the time, and then select G, and the result set is now grouped by the registration date. So we have seen few examples, and in the next video we will do some practical. We will do some modeling, or either we will generate the model from the database, or we will do the modeling first and then generate the database from the modeling, and then try to execute some queries.